Hi students, we're all live. If you're all live, give us a small confirmation about the audio, video and everything. शायद हम लोग live हैं. Yes, we are live. So this is good afternoon, Suresh VSR for Unacademy Flux Channel. एक बहुत ही नोवेल कॉन्सेप्ट है, पहली बार कर रहे हैं हम लोग भी. एक स्टूडेंट का लाइव मॉक इंटरव्यू ले रहे हैं हम लोग. We are taken for ISRO. We have really conducted such mock interviews for ISRO. But in that we were actually not recording, neither we were actually putting it in YouTube. So a lot of demand came कि सर हम भी देखना चाहते हैं कि mock interview होता क्या है, mock interview के बारे में थोड़ी idea चाहिए. But no student could really come forward for a recorded and that too live session, एकदम सीधा live. So we have with us Vakil Kumar from Patna, Bihar. And one of my student also, very proud to say that he is my student. So he has come forward for this. So we have a mock interview going on. And the other panel member along with me is Professor Dr. K. Niranjan Reddy. He has been my associate for the last 21 years. We have been very close friends and also my senior. He is also my boss, ex-boss, ex-HOD, head of the department. K. Niranjan Reddy Garu, doctor. So he's an VLSA expert. He's MS from UK, London, VLSA expert. So we'll take the panel students. So thank you all students for joining us live. Please share and like this session. एक छोटी सी encouragement है, like this session, encourage us, nothing more than that. So Niranjan sir, over to you.
Yeah, thank you Suresh. Vakil.
Yes sir.
Yeah, very good afternoon. Now, introduce yourself briefly so that we can go for questions.
Good afternoon, sir. My name is Vakil Kumar. I am from Samastipur district, Bihar. I have done my matriculation from my native place itself in 2011. Thereafter, I have done my intermediate from also my native place in 2013. And then after I have done my Bachelor's of Technology in Electronics and Communication Engineering from MIT Muzaffarpur, Bihar. Currently, I pursuing my Master's from IIT BSU in VLSI, and my hobby is listening songs. Thank you, sir.
Okay, right, very good. So, your favorite subject is VLSI. So, let me start with a small basic question. Right. So when we talk about the VLSI, we generally go for the MOSFETs, right?
Yes, sir.
So why we are not going for BJTs? Why only we are concentrating on MOSFETs? Is there any particular reason that you have?
Sir, actually, in MOSFET there is no any concept of thermal runaway like because here gate current is zero, and also in MOSFET. More circuit can be designed using fabrication process. So, here chip compatibility is more like BJT, and also BJT is not symmetrical device as we cannot interchange emitter and collector. So, but here in MOSFET is symmetrical device.
Okay, very good. One more question related to this only, right? When we go for the MOSFETs, we have got two types of MOSFETs. One is the enhancement, other one is a depletion mode. Which one is advantageous? Which one is popularly used in the market?
Enhancement mode, sir.
Why?
Enhancement mode.
Why we use that enhancement mode? What do you mean by that enhancement mode?
Sir, actually, enhancement mode, there is no channel previously. So we have to create a channel. But in depletion mode, there is already inbuilt channel. So more advantageous is enhancement mode.
Okay. Right.
PMOS, NMOS, CMOS, इससे भी आप कंपेयर करके बता सकते हो, मतलब सर ने जो पूछा वो इट्स नॉट डिप्लीशन एनहांसमेंट अलोन, आप पीमॉस एनमॉस सीमॉस से भी कंपेयर कर सकते हैं। एंड यू कैन ऑल्सो गिव जस्टिफिकेशन कि सीमॉस अल्टीमेटली क्यों यूजफुल है, थोड़ी आप उस पर एलोबरेट कर सकते हैं अबाउट सीमॉस।
Sir, actually, CMOS consists of NMOS and PMOS, and here PMOS acts as active load, and NMOS acts as actually PMOS acts as a pull-up network, and NMOS is a pull-down network. So it is basically a very preferable device. Here we can apply 0 to 5 volt in more proper way, like NMOS or PMOS.
Okay. Right.
Do you have any questions?
One question from my side. Yes, sir. One question from my side, Vakil. You know, BRC is one of the most prestigious organizations for nuclear research in India.
Yes, sir.
If you are selected, how many years minimum are you likely to serve for BRC? मतलब आप कितने साल कम से कम रह सकते हैं, मतलब कुड बी ट्रिवियल, लेकिन आपके करियर को देखते हुए आपकी एक्सपेक्टेशंस क्या हैं?
Sir, actually, I like research type courses and research type environment. So I think that I can join not सर ये कोई फिक्स बता नहीं सकते हैं कितने साल तक, बट मुझे बहुत इसमें इंटरेस्ट है रिसर्च और ये लर्निंग प्रोसेस में, तो सर हमेशा उसमें हम कंफर्टेबल रह सकते हैं सर।
Yeah, right. One more question in addition to Suresh question only, extension. Youngsters, most of the youngsters are preferring to go for software side. So why you have chosen this? Just out of curiosity.
Sir, actually, from first year onwards, I am very passionate about ISRO, BARC, and DRDO, like research organization. So I am not focusing that much in coding area. Only technical domain I just
Right.
core electronics technical.
You core side, right. Good, very good.
It's a very good answer. It's very good. कोडिंग एंड सॉफ्टवेयर प्राइवेट जॉब्स हर किसी को, मतलब हर किसी का काम का नहीं है, यू नो, मतलब मेनी पीपल डोंट प्रेफर इट, क्योंकि उसमें जो नेचर है, उसकी जो वर्क कल्चर है, हर किसी को सूट नहीं करती है. वी नीड कोर टेक्निकल एरिया या अपना रिसर्च एरिया. दीज आर ऑल एरियाज विच रियली मोटिवेट पीपल. सो दैट्स वेरी गुड आंसर वकील, वेरी गुड आंसर. तो निरंजन सर, एनी अदर क्वेश्चन? टेक्निकल सब्जेक्ट्स, व्हाट आर योर फेवरेट सब्जेक्ट्स? वकील कुमार, आपने कुछ सब्जेक्ट्स चुन के रखा है?
यस सर. सर माय फेवरेट सब्जेक्ट इज एनालॉग इलेक्ट्रॉनिक्स, डिजिटल इलेक्ट्रॉनिक्स, नेटवर्क, सिग्नल सिस्टम.
सिग्नल्स एंड सिस्टम्स में एक इम्पल्स फंक्शन, क्या ये फिजिकली आप रियलाइज कर सकते हो या ऑन पेपर मैथमेटिकली होता ही है? इम्पल्स फंक्शन रियल लाइफ में रियलाइज करना पॉसिबल है या सिर्फ ऑन पेपर मैथमेटिकल होती है, एक एक्सट्रीम केस होती है?
सर फिजिकली रियलाइज नहीं कर सकते हैं, बट एक लिमिट तक इसको कर सकते हैं सर.
टाइम डोमेन में या फ्रीक्वेंसी डोमेन में?
टाइम डोमेन सर. इम्पल्स फंक्शन एक टाइम डोमेन.
सो इम्पल्स फंक्शन फिजिकली काफी छोटी सी पल्स हैं, so you can reduce the time to few nanoseconds or microseconds and approximate it as impulse function, or it is practically a rectangular function. So impulse function rectangular function के एक limiting case है.
Yes sir, we can go up to a microsecond.
Okay, nanoseconds तक भी मुमकिन है, आज की टेक्नोलॉजी में नैनोसेकेंड्स में मुमकिन है. तो सिमिलरली फ्रीक्वेंसी डोमेन में जो सैम्पलिंग फंक्शन होती है वो एक्सपैंड होके लगभग स्ट्रेट लाइन फंक्शन हो जाती है. तो टाइम डोमेन में कितनी नैरोली कंप्रेस कर रहे हो आप, रेक्टेंगुलर फंक्शन से इंपल्स की ओर जा रहे हो, उतनी सैम्पलिंग फंक्शन बन जाती है स्ट्रेट लाइन फंक्शन. So when your rectangular function
Yes.
becomes impulse, sampling function becomes a straight line function. So
Yes.
इसके बीच में limitation होती है. This limitation is what you should be explaining them very clearly. ठीक है ना?
Yes.
Right. So निरंजन सर आपकी तरफ से कोई questions?
Yeah, Suresh. Coming on to that, digital electronics is one of your favorite subject. The very basic and the first question that you can expect is from this is, what is a latch and how it will be differ from flip-flop?
Sir, latch is basically a 1-bit memory cell, and flip-flop is also a 1-bit memory cell, but it's extra input that is called clock. And the latch is edge triggered, sorry, level triggered, but flip-flop is edge triggered.
Flip-flop is edge triggered, right?
So flip-flop is more preferable than latch.
Okay. Okay, right.
So very good. वो triggering mechanism में है edge triggered and end starting triggering. इससे pulse counting में काफी काम आएगा. It's useful in pulse duration counting and such things. So triggering में फर्क है, वो थोड़ी आप elaborate कर सकते थे. You could have elaborated, but triggering में फर्क है. Latch and flip flop में the triggering sequence has got a difference, right? That's it. Okay.
Yeah, you can talk about that level trigger and edge trigger, how it differs. And because there is a level, you cannot find exact time when it triggers, right? But in the edge, at the occurrence of the edge, it
You
triggers.
can find exact time.
Yes, exact triggering time. That's what you can say that. Okay. So coming on to the one more question. You know the decoder and encoder, right?
Yes.
Yeah, in the encoders, generally, most of the time we go for the priority encoders.
Yes.
So why this priority encoder is needed when we compare with normal encoders?
Yes. So actually, encoder takes a binary input and actually takes a normal input and give output in the form of binary sequences. But encoder at a time only one, if any encoder at a time only one inputs will be high, then only it gives proper output. But in some special case like more than one input will be high, then encoder does not handle this input. So we have to go priority encoder.
It could be like this. You can take out of octal to binary encoder, like that 8 to 3 encoder. You can say that if more than one inputs are present at the high level, then for a normal encoder, what will happen is it doesn't know how to determine the output. So what we do is we go for the priority. So if we assign the priority, then whichever is having the highest priority, that appears as that input, irrespective of the down level, the highest prior level one will be encoded. So that is what is the priority encoder, right? So in most of the time we go for the priorities, right? So if you go for the microprocessors, there will be a interrupts will be there. So there we go for the priorities, right?
Priority encoder.
So priority.
You can also flash that ADC.
Yeah, right. Wherever it is, the priority that we assign that priority according to priority that it will act. Okay. Right.
So Bhavna Singh and Advait has got a very good discussion continuing on this in the live chat, and I'm very happy both of you students. You've been talking about priority encoder and how to convert the. But Advait के question है, शायद वकील आप आंसर कर सकते हैं. Which simple circuit can you use to make a circuit level trigger to edge trigger? कौन सी सर्क्यूट से आपकी अरेंजमेंट लेवल ट्रिगर से एज ट्रिगर हो जाती है? दैट्स व्हाट अद्वैत इज आस्किंग. इफ यू कैन आंसर इट. यू कैन, अगर आप चाहे तो आंसर कर सकते हैं, अदरवाइज वकील आपके लिए.
Simple differentiator circuit.
Differentiator circuit. Bhavna has already gave the answer as RC circuit. So yes, RC circuit is differentiator. Excellent students. So हमारी पैनल 2 टेक्निकल मेंबर से 4 की ओर जा रही है. 2 more from the audience also. So really, it's very interactive. Thanks a lot, students. In fact, Vakil, आपने जो motivation दिया में, coming forward, and Niranjan Reddy sir really taking time from his schedule. My HOD taking time and coming out. Really, it's a great pleasure for me. So we'll continue the questions. Niranjan sir, you can go ahead with his next questions.
Yeah. When we come for the integrated circuits, that are linear and digital integrated circuits, one question from that, we have one concept called virtual ground, which plays very important role in operational amplifiers. Can you explain that? What is that virtual ground, okay?
Sir, actually, in operational amplifier, whenever we take an ideal operational amplifier with negative feedback, then inverting and non-inverting, both terminal acts like same potential. This is because of negative feedback, and gain should be very high. So it acts like at same potential. This is called virtual short.
See, the thing is, the input impedance is very high, right? So no signal can't go in. That's why, both will be at the virtual ground. We will be saying, okay.
Yes.
One more related to that only. We have got one more thing is called a 555 timer, right?
Yeah.
Do you remember? Yeah. Why it is so called as a 555 timer?
Actually, there are three resistances of 5 kilo ohm value. So I think.
Yes, there are 5 kilo ohm resistors, and they form a potential divider circuit, right?
Potential divider, yes.
Potential divider circuit, right? 1/3 of ECC, 2/3 of ECC. You might have gone through the block diagram of it. When we go for the internal block diagram of it, it will be a potential divider circuit. So that's why 5 kilo ohm resistors are present in the block diagram. So we will be calling it as a 555 timer. And why it is timer? Based on these resistors, that we are going to find the RC time constant. Okay, so that it is going to operate in astable mode, monostable, and bistable.
Monostable and bistable mode.
Three stable. Okay, right.
Yes.
Okay, Suresh, any other from your side?
Yes, sir. Vakil, what are the major hardware portions of VLSI? सॉफ्टवेयर तो आप फ्रंट एंड टूल्स तो हम जानते ही हैं, कैडेंस टूल्स, पी स्पाइस. तो इसमें हार्डवेयर कंपोनेंट्स वीएलएसए में व्हाट आर द मेजर कंपोनेंट्स? हार्डवेयर रिलेटेड, इंप्लीमेंटेशन रिलेटेड, हार्डवेयर टूल्स, आपके किट्स.
Many sir, like different ICs.
आईसी फैब्रिकेशन तो होता नहीं है. इवन इन इंडिया ऑल्सो वी डोंट हैव मच फैब्रिकेशन. तो हार्डवेयर में फैब्रिकेशन की कमी की वजह से कैसे जनरल पर्पस टूल्स यूज करते हैं? अब लैब में हार्डवेयर बोलिए तो ऑसिलोस्कोप, ब्रेडबोर्ड, पावर सप्लाई, ये लैब के हार्डवेयर हैं. तो रियल लाइफ में वीएलएसए हार्डवेयर, व्हाट इज द हार्डवेयर दैट यू एसोसिएट विद वीएलएसआई एंड वीएलएसए फैब्रिकेशन? किस पे आप इसको इंप्लीमेंट करते हो? आपने सर्किट बना दिया, आपने डिजाइन कर दिया, फिर उसको कहां पे इंप्लीमेंट करके बेचोगे उसको?
Where do you test? Sir wants to ask, where do you test?
Where do you test it? Where do you download the code? You know it, Vakil. You just recollect it, no issues. Feel free. You've been excellent so far. Your body language is good. Confidence अच्छा है. Feel free. Bharat Raheja is saying PCB, not exactly PCB, it's FPGAs. Majorly, we have ASICs, application specific ICs.
Yes, sir.
Majorly FPGAs. We also take a group
FPGA, and we have CPLD.
CPLDs. So Niranjan sir
And,
can.
nowadays zinc boards are available for you. There are many hardware boards are available for you, right? So CPLD and FPGA are the basic boards where you can download the program and you can test the functionality of it. Okay, Suresh.
Yeah. Yeah, thank you, Bharat, Raheja, and Advait. Superb answer from Shubham, especially. In fact, Tesla has got a question from Signals and Systems. Why no duality prop for DTFT? I mean, why there is no duality property for DTFT? Any idea? It's fine. You can answer it. Otherwise, Tesla will come and answer it. It's
Yes.
not a big thing. And of course, Bhavna Singh is also has got a very good question. These questions, please, all of you can note down them. What Bhavna has asked and Advait has asked, they've been really top quality questions. So you can also note down the question. If our person is not answering,
Yes.
no issues at all. But good. वकील आपको पहली 5 मिनट वहाँ पे बीआरसी में कंफर्टेबल किया जाएगा. They'll make you comfortable. They'll ask your favorite subjects. यहाँ पे तो हमने of course we have directly come to the point because it's a half an hour schedule of interview. बट वहाँ पे इंटरव्यू चलेगा 45 मिनट से लेके 1.5 आवर तक. तो दे विल मेक यू कंफर्टेबल अ लॉट. बट जो कोर क्वेश्चंस होते हैं इसी लेवल के होते हैं, इसी तरीके से होते हैं. बट दे विल गिव यू लॉट ऑफ टाइम. आपको शायद काफ़ी ज़्यादा टाइम मिलेगा. हमने टाइम भी थोड़ी कम दिया बिकॉज यू बीन आंसरिंग वेरी वेल. इनफैक्ट आपके आंसरिंग का भी तरीका अच्छा है. सो फाइन, लॉट ऑफ क्वेश्चंस आर कमिंग फ्रॉम आवर साइड. One question from Bhavna Singh is very interesting. What is a low pass STC circuit? What is a low pass STC circuit?
STC.
Yeah. Bhavna is asking low pass STC circuit. STC. It's okay, fine. Niranjan sir, you can go with the next question.
Yeah. One question is that can you compare risk and CISC? There is one of the very important question. Most of the time, this question will be asked in any of the interviews. Okay.
Yes. Yes, sir. Question. Please repeat the question.
Risk. Okay. Risk and the CISC.
Risk and CISC. Yes.
Mhm.
Sir, actually, risk and CISC are two types of computer architecture. Risk.
Yes.
Risk actually risk consists of
It's a reduced instruction.
less,
That is a
yes, sir, less
complex.
number of instructions, and CISC consists of more number of instructions. Actually, Intel and some other. Actually, Intel prefers CISC architecture.
Okay. Okay, right. One more question. Nowadays, most of the companies that they are looking for the other technology rather than the CMOS technology, right? You know the CMOS technology, right? So most of our hardware equipment like mobiles or laptops or whatever it is, everything will be manufactured using only the CMOS technology. Nowadays, Samsung is using a FinFET technology as well, right?
Yes, yes.
Samsung, a few of the mobiles that they are using FinFET technology, right? So why it is necessary to look for the other technologies where CMOS is very simple and easiest technology that we can go for? Why we are going for the other technology like a FinFET, one technology, the other one technology that what we call is as a TFET, tunnel FETs. You may be aware of it or not, I don't know, but it's better that if you are aware of these two, when you say that VLSI is your interested area.
FinFET already Bharat J and Bharat Jaswani and Bhavna Singh are discussing in live chat also FinFET. So it's very really kind of them, really helpful. Gaurav Kumar is asking questions on EMT. गौरव ईएमटी का क्वेश्चंस पक्का मेरा वकील बता देगा. मेरा वो स्टूडेंट है वो. सो ट्रांसमिशन लाइन्स के क्वेश्चंस पक्का ही आंसर इट, नो डाउट अबाउट इट. बट उसकी एमटेक वीएलएसए से हैं, तो वी आर हेल्पिंग हिम मोर ऑन वीएलएसए बेस्ड एरियाज. तो स्टूडेंट बिकॉज ही बिलोंग्स टू वीएलएसए एंड हिज रिसर्च इज इन दैट, तो हम लोग उसको थोड़ी मदद कर रहे हैं बस. सो फिनफेट के बारे में कुछ बता सकते हैं? यू कैन श्योरली एनकरेज अस.
The FinFET is the advanced version of MOSFET. Actually, in MOSFET, some problem like speed, uh, speed, noise margin, and fan in, fan out. So all problems are can be eliminated by using FinFET technology. FinFET actually very fast and cheap area also very less compared to MOSFET.
Okay. So one thing that FinFET technology, why most of the companies still not using means it is a bit cost when compared with these, right? That is one thing that
Yes,
we can
costly. It is costly.
costly. That's yeah. The other thing is FinFET has got more advantages when we compare with the CMOS technology. That's why companies are looking towards, because why CMOS technology is not they are using means as the size of the transistor is reducing, so automatically the length of the channel is getting reduced. So we are almost at the stage where the source and drains are come in contact with one with each other. So what will happen automatically? There will be a short circuit. So we are looking for the other technologies where we can implement. So the alternate technology that we go for is FinFET. Okay. Okay, Suresh.
Yes, sir. So overall, Vakil, your confidence and the way you're answering is very good. And just go through your BTech project once. BTech project has an importance. And also find out the latest projects of BRC in a few areas. कौन सी प्रोजेक्ट्स कर रहे हो लोग, उसका थोड़ी जानकारी रख लीजिए, ताकि उससे रिलेटेड जो भी सब्जेक्ट्स है वो उस पर कमांड हो तो बेहतर है. कंट्रोल सिस्टम्स इज अनडाउटेडली इंपॉर्टेंट. अगर आपको उस पर कमांड हो तो बेहतर है. कंट्रोल सिस्टम्स इज अनडाउटेडली इंपॉर्टेंट. थोड़ी इंस्ट्रूमेंटेशन का आइडिया हो तो भी बेहतर है. बट योर VLSI का आपका जो बैकड्रॉप है वो पक्का काम आएगा. इट्स श्योरली गोइंग टू बी वेरी यूजफुल इन विथ रेस्पेक्ट टू दैट. सो कैन आई आस्क यू अ फ्यू क्वेश्चंस फ्रॉम एनालॉग इलेक्ट्रॉनिक्स or any other subject other than VLSI or any other subject?
Yes, analog, network.
Okay. If you come to analog electronics, FET, small signal model, how many components does it overall have? उसके small signal model में कितने components होते हैं overall? Can you just count and tell me? फेट का स्मॉल सिग्नल AC मॉडल में कितने कंपोनेंट्स होते हैं? शायद वेरी इजी बट टेक टाइम.
Three internal capacitor.
लो फ्रीक्वेंसी में.
At low frequency, only GM-V5, dependent current sources, and input impedance could be very high, so it can be neglected open circuit.
So only two components.
Yes.
कितने components? दो ही components होते हैं, एक current source और एक output resistance.
Output is yes.
BJT का small signal model में approximate करने से कितने components होते हैं? How many devices make a BJT's approximate model?
Here, sir, input impedance is medium, like kilo ohm only, so HI also are included, and dependent current source, and output impedance could be output impedance like mega ohm, but also can we take output impedance HOE.
मुझे नंबर गिन के बता सकते हैं?
But two, sir, only two. Input impedance and dependent current.
No, approximate model में तीन होते हैं. Input impedance, output में current source और आउटपुट इम्पिडेंस भी. आउटपुट इम्पिडेंस आपने इग्नोर किया. ओके, व्हेन अर्ली वोल्टेज इज वेरी हाई. आउटपुट इम्पिडेंस बहुत ज्यादा है तो इग्नोर कर सकते हैं, ठीक है. R0 को भी इग्नोर कर सकते हैं, बट प्रैक्टिकली इनपुट इम्पिडेंस HI या R पाई या RE जो भी कहिए, आउटपुट में R0 और एक करंट सोर्स विच इज वोल्टेज डिपेंडेंट GM into Vin. सो 3 होते हैं BJT में. FET में 2 ही होते हैं. So AC analysis is very easy, right?
Actually, sir, output impedance के पैरेलल अगर हम लोड कनेक्ट करते हैं, सर वो लोड एक्चुअली वहाँ पे डोमिनेट करता है, वहाँ पे आउटपुट इम्पीडेंस नेगलेक्ट कर सकते हैं, मेगा ओम और लोड इम्पीडेंस किलो. तो
RL ही अक्सर वही रह जाती है. That is what is left out, and R0 can be taken as infinity, right? One last question: what is power amplifier, and why do we talk of power transfer efficiency rather than gain in power amplifiers? पावर एम्पलीफायर्स में गेन हटा के पावर ट्रांसफर एफिशिएंसी जैसी वर्ड क्यों यूज करते हैं?
Sir, actually, we use power amplifier for to
स्लोली रिलैक्स, सोच के बताइए.
सर एक्चुअली यहाँ पे डीसी इनपुट को एसी आउटपुट में कितने एफिशिएंटली कन्वर्ट कर पा रहा है मेरा एम्पलीफायर, यहाँ पे वो निकालते हैं. तो पावर ट्रांसमिशन कन्वर्शन एफिशिएंसी निकालते हैं, मींस कितना डीसी पावर कितने एसी पावर में वो कन्वर्ट कर पा रहा है.
एग्जैक्टली. एसी सिग्नल कितनी एम्पलीफाई हुआ, उसकी वोल्टेज कितना बढ़ा, उसकी करंट कितना बढ़ा, उससे ज्यादा वी टॉक ऑफ हाउ मच ऑफ द डीसी पावर हैज बीन कन्वर्टेड इनटू एसी सिग्नल. सो डीसी पावर को हमने कितनी सक्सेसफुली अटैच किया एसी को, ये मान्यता रखती है, rather than just increasing the amplitude of the signal, how powerful the output signal is. So that's why power transfer efficiency is very important, right? And most often we reduce the amplifier's power consumption ability. मतलब एम्पलीफायर में बायस रेसिस्टर्स हटा के उसका VCE इंटू IC प्रोडक्ट हटा के पूरी की पूरी पावर AC सिग्नल में बदल देते हैं. We try to see that amplifier is not consuming any power. So we try to see that there is no bias resistors, unwanted VCE, unwanted IC. पूरा का पूरा हम यही कोशिश करते हैं कि AC सिग्नल गेट्स पावरफुल, एम्पलीफायर इज नॉट कंज्यूमिंग एनी पावर. डिजाइन ऐसी होती है, दैट इज व्हाट इज क्लास बी डिजाइन, क्लास सी डिजाइन, सैचुरेशन में कट ऑफ में ऑपरेट करना ताकि एम्पलीफायर इज नॉट कंज्यूमिंग एनी पावर. आई होप यू गॉट इट. सो गुड वकील फ्रॉम योर साइड, रियली वेरी गुड. Vakil, you there? Any bandwidth problems? So students, stay back. We'll come back with the next student. So don't go away. We are there with the next student. He'll join us very shortly. So just give us 3 minutes time. We'll be back with joining with the next student. So stay live. Stay on, students. Give us 2 minutes. We'll be back with the next student. Neeru, just joining Neeru. Okay, just yeah, it's all fine. Yeah, ఈ లోపల అక్కడ యాడ్స్ పెట్టాను. I'm just joining. Yeah. Just joining 1 second. Yeah, it's launching. Yeah, you can join.
Good afternoon, sir.
Hi, Bharat. Bharat Jaswani. You're Akash, right? Akash also, I think.
Akshay.
Yakshay, yeah, nice. Just could identify you. So you're very active in the chat. I will just start it then. शुरू करते हैं.
Yes, sir.
Niranjan sir, you're ready?
Yeah, I'm ready, Suresh.
Yeah. Yeah. So I think we are back live, students. Just give me a small hint if we're all back live. Gaurav, yeah, I think we're all live. So Bharat J, Bharat Raheja, okay, they're two different students. So are we all live, students? Just give me a small hint. Yeah, we are live. Niranjan sir, you're ready?
Yeah.
So welcome back, students. We are with second aspirant for BRC today, Bharat Jaswani. He has been in fact active in the live chat so far, asking a lot of questions, helping us a lot. He has been a very sincere student in most of my classes. I could find him. So congrats first of all for clearing your written exam. And yeah, you can introduce yourself now to the panel, Dr. Professor K. Niranjan Reddy. He's also my ex-boss and my HOD and my colleague and my friend for the last 20 years. So please introduce yourself.
Okay. Sir, I am Bharat Jaswani and I have completed my BE in the year 2020 from Oriental Institute of Technology with an aggregate CGPA of 9.06. And currently I am working as an assistant software engineer at TCS. And I have been majorly working in the testing area, software testing for Nissan cars.
So Niranjan sir.
Okay, right. Very nice that you are working in software. And now the first question is, why do you want to come to this area?
Because I'm interested in core domain. I've been trying since 2-3 years, but was not getting any chance. So now, as I've got chance, so I want to make the best of it.
Very good, very good. Okay. Now, what are your favorite subjects?
Analog electronics, digital circuits, network, signals, and ADC.
ADC, right. So you said that EDC and analog electronics expert is here, that's Suresh, right? And I just want to ask one question from EDC. When we go for C amplifier, the output is phase shifted. Why?
Yes. Because we are taking output from the collector terminal, and if we draw the model of that BJT, then we see that the dependent current source is in the opposite direction of the output resistance. So when we invert it, the gain changes by 180 degrees.
180 degrees, very good, right.
But why do you put it downward? Why can't you put it upward itself? That arrow you could have put it upward and say it's in phase, right?
Yeah,
you are putting it
because
down.
It will change. Yeah, it will change that basic current equation of the MOSFET. IC plus IB is equals to IE. If I am putting that dependent source in the opposite direction, then IC will be with negative sign. It won't be in additive with a base to provide emitter current.
No, actually the simple logic I can answer is, if you increase your input base current because of increasing voltage, your output voltage VC will decrease ना, because IC will increase. कलेक्टर करंट बढ़ गया तो VC का वोल्टेज ड्रॉप हो जाएगा ना, क्योंकि वोल्टेज अक्रॉस RC विल इंक्रीज. तो VC क्या होगा? VCC माइनस IC इंटू RC. सो आप इनपुट वोल्टेज अगर बढ़ाओगे तो करंट बढ़ के, कलेक्टर करंट बढ़ के कलेक्टर पे वोल्टेज कम हो जाएगा और एक हद के बाद वो सैचुरेशन में चले जाएगा. तो उल्टा हो रही है ना वोल्टेज के साथ, जबकि करंट के साथ इन फेस हो रही है. सो दैट्स द लॉजिक यू शुड बी आंसरिंग इट, राइट? Right. So feel free, Bharat. This is not a very formal interview. दिस इज टू गिव गाइडलाइंस एंड हेल्प यू. हम लोग ना आपको बीच बीच में गाइडलाइंस भी देते रहेंगे. वी वोंट गेट वेरी एग्रेसिव. बार्क वाले भी काफ़ी एग्रेसिवली क्वेश्चंस नहीं पूछेंगे. सो फील फ्री एंड रिलैक्स. आई नो यू आर वेरी रिलैक्स कैंडिडेट. सर निरंजन सर, you can just continue, sir.
Yeah. When we go to digital electronics in flip-flops, in JK flip-flop, there is one condition called race around condition. Can you elaborate that?
It occurs in level triggering actually. When the JK flip-flop is in toggle mode and we are keeping the flip-flop as level triggered, then it will toggle more than once if its propagation delay is less than the clock time. So which will lead to an unstable output, which is not desired. Actually, we want it to toggle only once, but it is toggling many times.
So how you remove that? How to overcome that?
We can use an edge triggered clock to remove it, or a master slave configuration also.
Master slave by using the master slave configuration, we will be removing it. Okay. Coming on to the other part, do you know something about microcontrollers?
Yes, microcontrollers they have inbuilt microprocessor as well as timer, small memory. It is a compact IC kind of thing in which everything is pre-built inside.
So what is actually this ARM? ARM is controller or processor?
ARM is controller.
Controller. Okay. Continuing in that only, do you know something about the RTOS?
RTOS.
Real-time operating
RTOS.
Real-time operating system.
शायद आपकी प्रोजेक्ट को काफ़ी करीब है ये. रियल टाइम ऑपरेटिंग सिस्टम जिसमें एंड यूजर कोई बंदा होगा और उसके साथ आपको इंटरेक्ट करनी है और उसके आंसर्स वेरिएबल होते हैं. जैसे आजकल वॉइस बेस्ड IVR सिस्टम आ रहे हैं. आई में सेलेक्ट 1, आई में सेलेक्ट 6. तो वैसे रियल टाइम मतलब यू कैन सेलेक्ट एनीथिंग. जैसे आप ATM मशीन में जाते हो, कभी आपने बैलेंस चेक किया, कभी आपने पैसे निकाला, तो इट इज कॉल्ड एज रियल टाइम सिस्टम. कुछ भी आउटपुट, कुछ भी इनपुट दे सकता हूं मैं, राइट. दे आर कॉल्ड एज रियल टाइम ऑपरेटिंग सिस्टम्स, राइट.
Kind of embedded system only.
Embedded system, no doubt, but it is not specifically for one purpose. वहां पे बंदा कुछ भी पूछ सकते हैं. जैसे स्मार्ट बॉट्स आ रहे हैं आजकल. ये आपकी गूगल नेस्ट हो गया, आपका एलेक्सा हो गया. उसमें हम कुछ भी पूछते हैं उसको. एलेक्सा टाइम क्या हुआ, एलेक्सा वो चलाओ, एलेक्सा ये चलाओ. So it is something that has to interact with a human being and take a decision in real time. It could be a gaming software, it could be a automatic chess playing software, anything like that, where it has to take a decision, in real time. और वो भी नैनो सेकेंड्स में, कभी माइक्रो सेकेंड्स में, उसके पास टाइम भी नहीं होती है. सो ऑल दिस आर कॉल्ड एज रियल टाइम ऑपरेटिंग सिस्टम्स. जबकि आपका विंडोज है, इट इज स्टैटिक. विंडोज में आप स्टार्ट बटन दबाओगे या यू मे हैव सम प्री डिफाइंड कमांड्स, दैट्स ऑल. उसके अलावा नहीं करना है. सो दैट्स कॉल्ड एज रियल टाइम ऑपरेटिंग सिस्टम. आपका कार का जो सॉफ्टवेयर है वो भी रियल टाइम ऑपरेटिंग सिस्टम है, राइट. निरंजन सर, यू कैन प्लीज कंटिन्यू विद.
Coming on to one more question from digital, what is the TTL? Do you know something about the TTL?
Yes, it is a logic family by which we design logic gates.
What is that TTL?
In that we use transistor and resistors configuration to build the circuit.
I am asking about the TTL. TTL is nothing but a transistor logic. So one of the logic family, yeah. But we have, as you said, that transistor and resistor, that is RTL logic, what we call it as.
Okay.
And we have one more family called DTL, diode, transistor, and logic. And out of all these, there is one more is called, which is fastest one. The question may
ECL.
ask for you, ECL, right? Emitter coupled logic. Why it is fastest?
Because it is non-saturated. When the BJT is going into saturation, so it needs some time to come back to cut off.
Right, right. Okay. Over to Suresh.
Yeah. So Bharat, your favorite subjects are EDC and analog also, right? Okay.
Yes.
Can you just elaborate something about continuity equation in EDC? सेमीकंडक्टर फिजिक्स में कंटिन्यूटी इक्वेशन है क्या है, उसके बारे में थोड़ी थोड़ी जानकारी दीजिए. कंटिन्यूटी इक्वेशन ईडीसी के व्यू पॉइंट से बताइए.
The carriers that will come inside any device, the same carriers should have to leave out of it. It is like the KCL equation in network theory. So the amount of carriers generated and amount of carriers recombined, amount of carriers coming inside that device and leaving out of the device, their overall sum should be 0.
Can you tell me with respect to recombination and minority carrier injection? क्योंकि कंटिन्यूटी इक्वेशन ईडीसी में या सेमीकंडक्टर फिजिक्स में एंट्री लीविंग से ज़्यादा रिकॉम्बिनेशन और माइनॉरिटी कैरियर इंजेक्शन से जुड़ा हुआ है. सो कैन यू एलॉबरेट ऑन दैट, हो सके तो.
If we are injecting minority carriers in any semiconductor, then few of the carriers will get recombined with the existing carriers in that semiconductor, and the remaining few will lead to a small current which will come out in the form of carriers through that device. As per me, I am not very sure.
आप सिंपली ये बोल सकते हैं कि कभी भी माइनॉरिटी कैरियर्स को इंजेक्ट करेंगे किसी भी मेजॉरिटी रीजन में, वो रिकम्बाइन होंगे एक्सपोनेंशियली विद टाइम एंड स्पेस. उसकी रिकॉम्बिनेशन जो होती है एक्सपोनेंशियल होती है टाइम के साथ एंड डिस्टेंस के साथ, नॉट लीनियर और एनीथिंग. दैट इज कॉल्ड एज कंटिन्यूटी इक्वेशन. वो रिकॉम्बिनेशन का जो कॉन्स्टेंट्स है ना, एक्सपोनेंशियल कॉन्स्टेंट्स, ये होते हैं लाइफ टाइम एंड डिफ्यूजन लेंथ, एलपी एंड टाउ पी. दैट्स कंटिन्यूटी इक्वेशन. सो कंटिन्यूटी इक्वेशन सेज दैट व्हेनेवर यू हैव माइनॉरिटीज एंटरिंग ए मेजॉरिटी रीजन, एक्सपोनेंशियल रिकॉम्बिनेशन टेक्स प्लेस. वो पूरा मैथ्स करने के बाद ये कंक्लूजन है फर्स्ट. इट्स अ सिंपल कंक्लूजन. गुड, यू कम वेरी क्लोज टू इट. वेरी गुड. डोंट लूज कॉन्फिडेंस एट ऑल. Questions, my questions will be very typical like this. They'll be like, even in interviews also, they ask a very typical question from anywhere. So just don't worry about it. Second question from my side. You know a MOS capacitor, right?
Yes.
What are the various modes that the MOS capacitor operates in?
Accumulation mode, depletion mode, weak inversion, and strong inversion.
Among these three modes, where can it work as a variable capacitor?
In depletion mode, because a depletion layer is built in that mode, which can act as a capacitor in parallel to it.
Beautiful. So you're very strong in the advanced areas. So I think I'll have to come back to semiconductor physics or have to come back to diodes. Okay. In a diode, you've got depletion region, right?
Yes.
In the depletion region, why is the electric field maximum at the center of the depletion region? डायोड के अंदर डिप्लीशन रीजन में एकदम सेंटर पे मैक्सिमम क्यों होती है?
Sir, maybe because on the p side there are negative ions, and on the n side, closer to the center, there are positive ions. So at the junction of which there is rate of change of charge, the maximum rate of change of charge. So maybe that's why the electric field is maximum at the junction.
That's also a good logic. That's a good logic. You can simply say electric field is a linear function in charge and inside a charge. चार्ज के अंदर इलेक्ट्रिक फील्ड होती है और वो बढ़ती है लीनियरली. तो बढ़ते बढ़ते बाउंड्री पे जब आती है वो मैक्सिमम है. काफी लोग ये सोचते हैं कि चार्ज के अंदर इलेक्ट्रिक फील्ड होता नहीं है. चार्ज के अंदर इलेक्ट्रिक फील्ड होती है और इट इज मैक्सिमम व्हेन इट इज कमिंग आउट ऑफ द चार्ज. बाउंड्री पे एकदम मैक्सिमम होती है. सो दैट केस कैन बी अप्लाइड हियर ऑल्सो. गुड. हमारे एक डाउट है फ्रॉम चित्रा. व्हाई इज ए फोटोडायोड यूज्ड इन रिवर्स बायस ऑलवेज? फोटोडायोड
Because depletion width is more in reverse bias, so it can more number of covalent bonds the light carrier can see, light photon can see in reverse bias. So because of which it can break that covalent bonds easily. Whereas in forward bias, depletion width is very narrow, so less number of covalent bonds it can see the incoming photon. So
Slightly deviated. Can you come back on track? थोड़ी सी डिविएट हो गई. फोटो डायोड को रिवर्स बायस में चलाने का क्या वजह है? शायद आई शुड गिव यू अ हिंट. ये स्विचिंग से रिलेटेड हैं, स्विचिंग से जुड़ा हुआ एस्पेक्ट है.
in reverse bias, the current is zero.
Very good.
Only minority carriers give rise to current.
Hmm.
And that is dark current. So when the photon is falling upon, we can easily detect because with the slight change in current, slight increase in current.
रिवर्स बायस में जो कि ऑफ होती है, लाइट इंसिडेंट होने के बाद ऑन होती है, ताकि वो लाइट बेस्ड स्विच बन जाती है इन रिवर्स बायस. वेयर एज इफ यू ऑपरेटेड इन फॉरवर्ड बायस, वो ऑलरेडी ऑन है, लाइट इंसिडेंट्स के बाद ऑफ तो नहीं होगा ना वो. सो इट बिकम्स अ लाइट कंट्रोलर, ऑटोमेटिक बेड लैम्प. इट बिकम्स एन एक्सीलेंट एग्जांपल ऑफ ऑटोमेटिक स्ट्रीट लाइट्स. सोलर पैनल्स काम करने के लिए, ओपन और क्लोज करने के लिए. तो लाइट बेस्ड स्विचिंग जहां पे भी चाहिए, फोटोडायोड यूज करते हैं, ताकि वो ऑन व ऑफ वाली डिवाइस ऑन हो जाती है लाइट के हिसाब से. बट डायोड इन फॉरवर्ड बायस इज ऑलरेडी ऑन. व्हाट कैन यू डू एडिशनली विद लाइट विथ इट? गॉट इट? Good student, very good.
Yes.
Really thanks first of all for coming forward and motivating so many students. आपकी वजह से काफ़ी questions भी आए यहाँ पे. Students are very actively talking, chatting, giving lot of questions. तो मेरी suggestion है students, please आप लोग थोड़ी सी answer भी बता दीजिए, क्योंकि हर question तो हम we can't ask Bharat and trouble him. So please tell the answers also. Wherever possible you can please discuss, and live chat में answers भी maintain कीजिए. Please give. मैं भी क्वेश्चंस पूछने की कोशिश कर रहा हूं, बट यू ऑल्सो प्लीज आंसर, राइट? सो थैंक यू ऑल ऑफ यू. आकाश, स्पेशली चित्रा एंड भारत रहेजा, थैंक्स विवेक सिंह, यू बीन वेरी एक्टिव. सो निरंजन सर, यू कैन टेक ओवर सर.
One last question, coming on to the digital again. When we go for the Karnaugh maps, right?
Yes.
We use the one special code in writing the numbering system.
Yes, gray
You may
code.
be aware of gray code. Why we use the gray code there? Why not the other regular binary code we don't use?
Because gray code provides us the flexibility of one bit change at a time.
Okay.
So all the minterms which we used in formation of SOP or POS have one bit change.
Okay.
When we are moving to the next one, that's why gray codes are used.
So when we go for the two successive numbers, so the number of bit change will be always a single.
One.
It's only one bit. That's why it is also known as a minimum bit change code. Okay. But when we go for the binary, what will happen? Sometimes it is an irregular pattern. Sometimes there will be only one, there will be two, there will be three as well. So like that's why we are when we are going for the Karnaugh maps, we are going for the gray codes. Okay. Right. I hope that you are confident in digital part. Right. So all the best. All the best.
Bharat, you just relax, have more body language which is more relaxed. Even in the interview also, slight body language, I want you to be more relaxed. Seems to be slightly tensed. वैसे वहाँ पे वो लोग आपको relax कराएंगे. Maybe we have just started off the interview because we are at a limited time of 30 minutes or 40 minutes. But वहाँ पे 1.5 hour तक चलेगा इंटरव्यू, तो आपको काफ़ी टाइम दिया जाएगा रिलैक्स करने के लिए. यू कैन इवन स्पीक इन हिंदी, यू कैन स्पीक इन इंग्लिश ऑल्सो. आप अपनी कन्वीनियंट लैंग्वेज चुन सकते हैं. एनीहाउ यू आर वर्किंग, सो मे बी यू आर वेरी कंफर्टेबल विद इंग्लिश एंड हिंदी बोथ. तो आप यू शुड प्रेजेंट ए मोर रिलैक्स्ड बॉडी लैंग्वेज थोड़ी सी. सेकेंड थिंग इज ए डाउट, स्मॉल डाउट फ्रॉम विवेक सिंह. व्हाट इज द डिफरेंस बिटवीन पुश पुल एंड कॉम्प्लीमेंट्री सिमेट्री? पुश पुल एम्पलीफायर में और कॉम्प्लीमेंट्री सिमेट्री में क्या फर्क है? और टेल मी व्हाट इज अ पुश पुल एम्पलीफायर?
In power amplifiers, push-pull configuration.
Yeah.
So we use it in class B kind of amplifiers to provide, to increase the efficiency mainly used to increase the efficiency. Not much aware about power amplifiers,
Okay.
but slightly I know
Yeah.
that it is
So
used to increase efficiency.
पावर एम्पलीफायर में सिंपली हाफ साइकिल एक ट्रांजिस्टर एम्पलीफाई करेगा, दूसरी हाफ साइकिल सेकेंड ट्रांजिस्टर विल एम्पलीफाई, ताकि एक 0 टू वी मैक्स तक एम्पलीफाई करेगा, दूसरा 0 टू माइनस वी मैक्स. दिस इज कॉल्ड एज पुश पुल कॉन्फ़िगरेशन, ताकि पीक टू पीक ओवरऑल इज गोइंग टू बी एम्पलीफाइड. दिस इज कॉल्ड एज पुश पुल कॉन्फ़िगरेशन. एक ही ट्रांजिस्टर से पूरा पूरा बाइपोलर सिग्नल को एम्पलीफाई नहीं कर सकते हैं, तो यूनिपोलरली एक ट्रांजिस्टर एम्पलीफाई करेगा, दूसरी पोलैरिटी के लिए दूसरी ट्रांजिस्टर है. दैट्स सिंपली व्हाट यू कैन कॉल इट एज पुश पुल एम्पलीफायर, राइट. जैसा साइकिल चलाते हो, एक पेडल ऊपर आती है तो दूसरी नीचे जाती है, वो आसान है ना डिजाइन में. तो फिर पेडल ऊपर गया फिर नीचे गया. दैट्स व्हाट इज अ डिजाइन इज, राइट. सो इट्स very good answer, in fact, no doubt about it. So Bharat, apart from EDC, analog, digital, any other favorite subject?
Network and signals.
Networks. I mean, it's not a very serious interview stuff, no doubt about it. But can you elaborate what is maximum power transfer theorem? आप maximum power transfer theorem के बारे में थोड़ी सी hint दीजिए मुझे. What is it?
Actually, whenever we make the Thevenin equivalent model of any circuit, the equivalent resistance, if we make the load equals to equivalent resistance or equivalent magnitude of equivalent impedance of it, then the maximum power takes place, transfer to the load. Maximum power gets transferred to the load because of impedance matching thing.
Okay. What is internal impedance of an amplifier? Internal impedance of an power source. किसी भी वोल्टेज सोर्स का इंटरनल इंपेडेंस का मतलब क्या है?
The amount of energy it can transfer.
Beautiful. Internal impedance is not a loss. It's not a lossy resistance. It is an idea of how much of power it can deliver. I square into R. तो इंटरनल इंपेडेंस को अक्सर लोग बोलते हैं कि वो नॉन आइडियल हैं इसीलिए आया, वो यूजलेस हैं इसीलिए आया. नहीं, वो गलत हैं. इंटरनल इंपेडेंस का मतलब कितनी पावर डिलीवर कर सकती है उसका अंदाजा है. उसको अगर रेसिस्टर मान लो तो कितनी पावर डिसिपेट कर सकती है. सो आई स्क्वायर इंटू आर एस इज द पावर इट कैन डिसिपेट. दैट इज इक्वल टू आई स्क्वायर इंटू आर एल. दैट इज द मैक्सिमम पावर इट कैन डिलीवर ना. So maximum power that it can deliver is the maximum power that it can generate from the source. That is equal to I square RS is equal to I square into RL. You got the point, students? Right. What is the significance of a unit step signal? हमारे विवेक सिंह का डाउट है. What is the significance of unit step signal?
Sudden change in any voltage or current in the circuit signifies step. For example, at the time of switching, when the supply is not connected to the circuit and we switch it on, at that time step change occurs. That's why we study transients also.
Okay.
Because some elements behave differently when there is a sudden change in the supply.
Fine, that answer is reasonably close to what I'm expecting. No doubt, undoubtedly it's right. You can also say it's a study of the transition from on state to the off state. So you can say that it is something that is going to signify what is the transient study, what are the frequencies that are produced in the transient and such things. So it's a good answer, right? Can you tell me what are the 4 feedback mechanisms in amplifiers? 4 feedback mechanisms in amplifiers, and what are you sampling in the output and what are you connecting in the input in each feedback? हर feedback में input क्या है, input में क्या दे रहे हो, output से क्या ले रहे हो? Can you elaborate?
Yes, current configuration is there in which we are sampling current and
no, just a minute. I want the answer in current series or current shunt, like that.
Okay.
Voltage series,
all these are different names topologies that are assigned. So current series signifies that we are sampling current and we are adding it in series. So to add it in series, we have to add voltages only can be added in series.
Good.
So
Beautiful.
we are sampling current and adding voltage, and then
Beautiful.
voltage series is there, in which we are sampling voltage and adding voltage only. Then voltage shunt is there, we are sampling voltage and adding current. Then current shunt is there, we are taking samples in the form of current and adding in form of current only.
Why I asked you this question is many people confuse between that series and shunt. Voltage measure करते हैं shunt में, add करते हैं series में. उसको measure करते हैं shunt में, parallel में, add करते हैं series में. Current को उल्टा, current is measured in series, added in shunt. तो इसीलिए voltage shunt, voltage series ऐसा बोलने से you understand what are you sampling in the output, what are you connecting in the input. You gave a very good answer, really. That was a very good justification about series and shunt sampling and series and shunt additions. So that's about a lot of questions coming from student sides. In fact, Vivek Singh काफ़ी questions पूछ रहे हैं. थोड़ी सी आंसर भी बताइए, Vivek Singh. Please put the answers also. Niranjan sir, any questions from your side or shall I continue, please, Niranjan sir?
Yeah, it's okay, Suresh.
From your side?
From my side, I'm right.
Okay. So Bhavna Singh also giving a lot of answers. Mock interview के लिए, in fact, I was really happy to conduct this mock interview. ISRO के लिए भी हमने conduct किया, but they were in closed doors actually. We conducted it with without any recording and without any knowledge to the outside world. That's because not every student may be interested in it. But thanks a lot, both of you, Bharat and Vakil, for coming here. The reason why we conducted is so that students have an idea of what sort of questions are being asked and what is the body language of the students. So, आप body language देखिए, they are very confidently answering, which they are not known. They are trying to put some reason behind it. कुछ reason देने की कोशिश कर रहे हैं. Or if they totally don't know it, they'll say, I don't know. But preferably BARC में try to figure out something. कुछ ना कुछ figure out करने की कोशिश कीजिए. अभी जैसे भारत को देखिए, he was trying to get close to the answer. He was very close to the answer. वकील कुमार को देखिए, he was coming very close to the answer. So we will continue this sessions surely, students. हम लोग इसको continue करेंगे. So thank you, Bharat, for coming, and thanks a lot for my friend and guide Niranjan Reddy garu, Dr. Niranjan Reddy. So thanks a lot, all of you students. Please like and subscribe this. Next Sunday also we'll continue with this session. So thank you, students. Thanks a lot. Take care. Bye, students. Bye.
Okay, Suresh. One last thing,
Yes,
suggestion
please.
to Bharat.
Okay. Yes, please.
As he is working with cars and all those things, yeah, I think control system plays vital role there, right? So if he makes his favorite subject as control systems, I think it's good for him to clear the things.
Okay, sir.
Okay, right. Okay, thank you. All the best.
Thank you, sir.
Thank you, sir.